Good everyone, my name is Graphics. In today's video, we want to learn on how we can apply the Bernoulli equation in solving problems involving flow in a pipe, right? And this problem, the question goes like this. It says the diameter of a pipe changes from 200 millimeter at a section 5 meter above datum to 50 millimeter at a section 3 meter above datum. The pressure of water at first section is 500 kilopascal. If the velocity of flow at the first section is 1 meter per second, determine the intensity of pressure at the second section. I will always tell you this. Whenever you are given a question in words, you have to write out the data given in the question, the parameters. So, data given. The question says diameter of the pipe. You should know we have two sections, section 1 and 2, or I say the first and the second section, right? So I'll be using a subscript of 1 to represent first section and a subscript of 2 to represent second section. So since it says that diameter of a pipe changes from 200 millimeter, that is the first section. So I'm going to be using D subscript 1, that is D1, to be equal to what? 200 millimeter. Now I have to convert my 200 millimeter into meter. So in doing so, I will be dividing by 1000. So dividing by 1000, I'll be having 0.2 meter. Now, when you ever calculate for diameter, always calculate for the area of that pipe also. And we know the area of that section of the pipe, A subscript 1, will be given as what? Pi D1 square over 4. Now, if I input my value here, I'll be having the pi times the value of D1 is 0.2 square all over 4. And doing the needful, I'll be having 0.03142 meter square. That is for that. Now we move forward. And I said at a section 5 meter above the ground. That means the 200 millimeter diameter pipe is at a section 5 meter above the ground. That is the datum, right? So we use Z to represent our datum, our height, and that will be given as what? Z1 will be equals to what? 5 meter. Now move forward to 50 millimeter at section 3 meter above the ground. Now we diameter of the pipe now what? It changes. That means it is now reducing, right? It changes to what? 50 millimeter. So I'm using D2 to represent that particular diameter there. So D2 will be equals to 50 millimeter. Converting it into meter, I have to divide by 1000. So 50 divided by 1000 will give us 0.05 meter, right? Now we need to calculate for what? For the area of that section of the pipe. So we use A2, and A2 here will be given as what? Pi D2 square over 4, and that will be given as what? Pi times what is D2? 0.05 square all over 4, and that will give us 0.001964 meter square. That is the value of what? The area 2. Now we'll move forward. It says that what? It is 3 meter above the ground. So we're using Z2 to represent that height above the ground of section 2, and that is 3 meter that we have there. Now move forward. The pressure of water at that first section, that is P1, is 500 kilopascal, right? So P1 is equal to 500 kilopascal. I have to convert it into Pascal alone, so it will be 500 times 1000, right? And that'll give us 500,000 Pascal. Is that taken? Or 500 times 10 raised to the power 3 Pascal. Now we move forward. It says if the velocity of flow at the first section is 1 meter per second, so we're talking about V1 now, equals to what? 1 meter per second. Determine the intensity of pressure at the second section. Now we are told to determine the intensity of pressure at the second section, which is what? P2. We're looking for it. Now, since V2 is not given here, we need to look for V2 also. So we say V2 here is also what? Unknown. Now, this is the parameter that we have in this question, right? Now, I need to show you a diagram that will tell you more about what this question is talking about. Now, this is what the diagram is all about, right? This is the first section here. The height of is lifted 5 meters above the datum, right? And this is the second section. It is lifted 3 meters above the datum. Is that taken now? So this is what we have here. This is your Z1 and your Z2. Now we move forward. Now if you look at this closely, the first we calculate for to get is our velocity. Since we have V1, we must have V2 also, right? So because we have two sections. So there's velocity in section 1, there must be velocity in what? Section 2. So calculating for velocity at section 2, right? We recall that the discharge at section 1 is equal to the discharge at what? At section 2, right? And what is the formula for discharge? Is given as what? Area times velocity. So it means that the discharge at section 1 will be area A1 times what? V1 equals to discharge at section 2 will be A2 times V2. Now if I input my parameter here, my A1 is given as 0.03142 times velocity at section 1 is what? 1 equals to the area at section 2 is given as what? 0.001964, right? Multiplied by the velocity at section 2. Is that okay now? So from what we have here, we will now make our velocity at section 2 the sort of the formula. So it will be 0.3142 times 1, which will still give you 0.3142 divided by what? 0.00196, right? So this is my velocity at section 2. So we'll now say that velocity at section 2 will now be equals to, when you divide these two values here, you'll be having your answer to be what? Your answer to be 16.03 meter per seconds. Is that okay now? 16.03 meter per seconds. So V2 will now be equals to what? 16.03 meter per second. So we've gotten our value for V2. Now we will now apply the Bernoulli equation. Now recall, we know that P1 over rho g plus V1 square over 2g plus Z1 is equals to what? P2 over rho g plus V2 square over 2g plus Z2. So because we have two sections, that's why we're having it in two places. Is that okay now? Now where P is given as what? The pressure intensity at section 1, that is P1, and the rho that is looking in form of the density times the gravity plus the velocity at section 1 square over 2 times the gravity plus the vertical height of the pipe at section 1 equals to the pressure intensity at section 2 over the density times the gravity plus the velocity at section 2 square over what? 2 times the gravity plus what? The Z2, the datum at section 2. Now if I start inputting my value here, the pressure intensity at section 1 that we calculated, that we were given in the parameters way, is what? 500,000, right? Divided by the density of water is 1000 times the gravity of water is 9.81, right? Plus velocity at section 1 is given to be 1, so we're having 1 square, divided by 2 times gravity, which is 9.81, plus the datum at section 1 is 5, equals to the pressure intensity at section 2, which we don't have, and that's what we're looking for, divided by 1000 times 9.81, that is density times gravity, plus 16.03 square over 2 times 9.81 plus 3, right? That is what we have there. Now if I do the needful, if I divide 500,000 divided by 1000 times 9.81, I'll be having 50.97 approximately, plus 1 square is 1 divided by what? 2 times 9.81, that will give us 0.05097 plus 5 equals to P2 divided by we have 1000 times 9.81, right? And that will be P2 over 9810 when you multiply both of them, plus if you divide 16.03 square divided by 2 times 9.81, we're going to be having 19.097 or 0.092 plus 3, right? 0.097 plus 3. So we'll move forward. Now, if you now add 50.97 plus 0.05097 plus 5, you'll be having 56.02, right? Equals to P2 divided by 9810 plus 16.097. When you add 13.097 plus 3, you'll be having 16.097. Now, if I take the 16.097 to the other side of the equal sign, I'll be having 56.02 minus 16.097. The sign will change to minus because it's crossing the equal sign to the other side. Equals to what? 50 P2 over what? 9810. Right? Now, when you subtract 56.02 from, when you subtract 16.097 from 56.02, you'll be left with 39.924, right? Equals to what? Equals to P2 over 9810. Now, if I cross multiply, my P2 will now be giving me 9810 multiplied by 39.924. And that will give us P2 will now be equals to what? 391,654.14. That will be having now Newton per meter square, right? That is the pressure at the section 2 of the pipe. So we can easily convert it to kilonewton per meter square, which will give us P2 equals to 391.65 kilonewton per meter square. And we also know that Newton per meter square means Pascal. So it can be 391.65 kilopascal. Is that okay now? So if you have actually found this video helpful, please don't forget to subscribe, like, comment, and also share the video. Thanks for watching.